Okay, so this is a video for section 3.6 for Algebra 2, and we're looking at 3x3 systems. And we're specifically looking at using the elimination method as the first step. Okay, so just like in the substitution method that we looked at already, we are just talking about the first step. And so remember that the overall goal is to eliminate one of the three variables in some way. So to do that, we're going to eliminate them using the elimination method. So you're going to pick a variable, any one, that looks easy to cancel out in two pairs of equations. So you have three equations, you're going to pair them up twice. So you're just going to look at a pair at a time. You'll basically do the elimination method with two pairs of equations, and here's a key idea. By canceling out the same variable both times. Okay, so looking at our situation here, if you look at the x's, we have 5x and negative x. I could cancel out those by multiplying this by 5, and I'd have a 5x and a negative 5x. Or I could do a negative x and the 4x. That's a different pair. Okay, so that's the ones I'm going to do. I'm going to do the x's, but I could do the y's, I could do the z's, but I think the easiest one in this problem would be the x's. So I'm going to multiply equation number 2 by 5 and then add it to equation number 1. So if I multiply this equation by 5, ignore the 2 here, I'm going to have negative 5x plus 15y minus 10z equals 0. Now 5 times 0 is 0. So I did multiply that. I didn't keep it the same. And then I'm going to add that to equation 1. So I'm going to put equation 1 underneath this, and I'm going to add, just like I would with the elimination method for 2x2 systems. Okay, so the x's cancel, and I have 11y's, negative 6z equals 18. So I have a two-variable equation. This is what we're going to call equation 4, just like we did with the last method. Okay, now I'm going to use another pair of equations to cancel out the same variable. So here I canceled out the x's. I need to cancel out the x's again. I could use, in this one I used equation 1 and equation 2. I can't use those two equations again. I have to use another pair of equations. I could do equation 1 and equation 3, 5x and 4x. Perhaps I can make a 20x and a negative 20x. But the easier option might be to do equation 2 and equation 3. So if I multiply equation 2 by 4, so instead of multiplying it by 5, I'm going to multiply it by 4. That would give me negative 4x plus 12y minus 8z equals 0. Again, I am multiplying the 4 times the 0 on the other side. It just happens to be staying the same because it's a 0. And then I'm going to copy equation 3. So I have 4x minus 2y plus 7z equals 3. And then I'm going to add those two equations together. Again, the x's cancel. That was my goal. And I have 10y looks like a minus z equal to a 3. This is equation number 5. Alright, so now that I have equation 4 and equation 5, I'm going to use my new equation 4 and 5 to solve for, in this case I have y's and z's, so I'm going to solve for y and z using either method that we learned in 3.2. In this case, I'm going to use the elimination method because that's just my preferred method. But you could use the substitution method. Okay, so I'm going to recopy these. 11y minus 6z is equal to 18. 10y minus z is equal to 3. So it's pretty easy to get the z's to cancel out. if I multiply that bottom equation by a -6. And the reason I want a -6 is so that these negatives will cancel and I get a plus 6z. So that gives me -60y plus 6z equals -18. Copy the other equation. 11y minus 6z is equal to 18. And add. Okay, so my z's cancel out. I have negative 49y's is equal to 0. So that means that y is equal to 0. I'm going to plug that in for y, and so I'll just use the top equation to get z. So that's 0, that cancels. If I divide both sides by -6, I get that z equals -3. Okay, so I already got 2 out of my 3 variables. Right, and I didn't use the elimination method here because I use the elimination at the top. That doesn't matter. I just used it because I thought it would be easier. Remember, this is like a problem within a problem. Okay, so then we need to solve for our last variable, which was the x. Solve for x by plugging in y and z. And so we do that in one of our original equations that has an x and a y and a z. I'm going to choose equation 2 just because the numbers are smaller, or it doesn't matter. So that was -x plus 3y minus 2z equals 0. And then I'm going to plug in my y with 0 and my z with -3 and solve this equation for x. So 0 doesn't do anything, so that's -x plus 6 is equal to 0. X would have to be equal to 6, because then -6 plus 6 would be 0. Okay, so remember in Math Excel you're going to have to write it as a point. In fact, it's basically like 3 blocks and you fill in each one. So just make sure you know it goes in order x, y, z. So this would be 6, this would be 0, this would be -3. Okay. I want you to try this one on your own. Okay. We'll go over it together on Wednesday in class, but I want you to try this one the best of your ability on your own. Okay, give it a try. All right, I am going to go over the easier cases on the back now. Okay, so you can, if you want to do the sample one, you can pause it, work on it, and then push play, or you could do that after the video. Up to you, but I do want to see that you attempted that one. Okay, so the easier cases, you may recall that I told you that I started with the harder cases because the easier cases are more like special cases. What you should know, or what you should notice in this example here is that the equations are a lot smaller. This one has all 3 variables, x, y, and z. This one only has 2. And this one only has 1. And that looks strange at first. But actually that makes things a lot easier because if you look at this equation right here, that is an equation you can solve. So if you ever see one where you have a variable just ready to go, you can solve it. Just solve it. Divide both sides by -7. Y is -5. Okay, well that is powerful information because I can now plug that in the other equations and perhaps it could solve something. For example, in equation 2, I have 2y minus z is equal to -15. I now know what y is, so plug it in. So 2 times -5 minus z is equal to -15. This is going to allow us to find what z is. So let's go ahead and solve for z. 10, negative z is equal to negative 5, so z is 5. So now I have y, I have z. Now I can go back to this top equation and plug those in to get x. So x plus 4 times y, which is negative 5, plus z, which is positive 5, equals negative 20. So x minus 20 plus 5, x minus 15 equals negative 20, add 15, x equals negative 5. Okay, so they're easier, right? There's not as much work to do. They're just different, and you have to know that just basically if you can find one of the variables right off the bat, do it. Then plug it in the other equations and solve it. Okay, this one's a little different. We have two equations that have three variables, and then one equation that only has one. Again, we can solve for y immediately using this second equation. Divide both sides by negative 5. Y would equal negative 3. Okay, so if I plug that in, I'm not going to be able to immediately find another answer, but you'll see what happens when we plug it in. It will reduce our equation. So I plug it in there. I get 2x minus 12 minus 6z is equal to 0. So this has two variables in it. And if I plug it into the other one, the equation 3, that'd be 6x minus 4 times negative 3 minus 2z is equal to 32. So 6x plus 12 minus 2z is equal to 32. So what I have here, this is like an equation 4 and equation 5, although I should clean it up a little bit. But then we're going to have to do a 2 by 2 system here. I'm going to clean it up by adding this 12 to the other side. And I get 2x minus 6z is equal to 12. And I'm going to subtract this 12. And I get 6x minus 2z is equal to 20. These are a system that I can now solve. This is a system here. Okay. I'm going to multiply this top equation by a negative 3. So that gives me negative 6x plus 18z is equal to negative 36. And then the system cancels out the x's, and I have 16z's is equal to negative 16. Z is equal to negative 1. And then I can find x by plugging, I can just plug it into one of these two equations. So 2x minus 6 times z, which is negative 1, is supposed to equal 12. So I'm using this equation. 2x plus 6 is equal to 12. Subtract the 6. 2x is equal to 6. X is equal to 3. Okay, I have all three variables here. Okay, that's it. We will practice this a little bit more next week, and we're also going to look at some word problems that have to do with this, but not just yet. Feel free to, you can get started on the homework, although the word problems are integrated into it, so you may not be able to do that just yet. All right, I'll see you guys on Wednesday.